Okay, students, on this clip, we're going to be going over how to graph some trig functions with asymptotes. We're going to be graphing the tangent, secant, and cosecant curves, okay? So the most important thing here is to note when these functions have their asymptotes, okay? So what creates an asymptote? Well, let's write it down. Whenever the function in the denominator is equal to 0, we have a vertical asymptote, okay? A vertical asymptote. So that will be the main focus of today's problem. Will be where are the vertical asymptotes, and that's basically what's going to determine how we construct our graph, okay? So for question number 1, graph the function y equals tan x from negative 2 pi less than or equal to x all the way to 2 pi. Okay. So the first thing you have to note is that a tan function is a quotient trig function. Okay. Y equals tan x is a quotient of two functions, sine x over cosine x. Okay. So where are the asymptotes? The asymptotes occur when the denominator function cosine equals to 0. So what we're going to do is, whenever cosine x equals 0, we have an asymptote. Okay? So what we're going to do is we're going to graph the cosine function and generate the asymptotes, then we'll put our tangent function. Okay, so before we start, just remember the tan function kind of look like snakes going up like this. So it's like a snake behavior graph, and it just goes up like that repeatedly on this entire interval. Okay, and it's separated by the asymptotes. Okay, all right. So let's focus our attention on the cosine first. So we're going to be looking at, since this is since this function right here we have in standard form is y minus 0, y minus 0 equals 1 tan 1 parenthesis x minus 0. We're going to be focusing our attention on the cosine version of this exact function to determine where our asymptotes are. So we're going to look at y minus 0 equals 1 cosine parenthesis 1 times x minus 0. Why are we looking at cosine again? Because cosine is the denominator, and the denominator tells us where the asymptotes are. All right? So this is a cosine function. Let's just write some information real quick. The new origin, we went over this in the previous clip. The new origin is 0, 0. The phase shift is none, since you move in no direction to the left or right. Vertical shift is none. Our amplitude is going to be 1, and that's 1 unit up and down. All right. Our period is going to be 2 pi over b. In this case, b is 1, so it's going to be 2 pi over 1, which is 2 pi. This goes side to side, and this is 4 ticks. Okay, don't forget the period, 4 ticks equals your period. So 4 ticks equals 2 pi. Okay? Alright. And then the frequency doesn't really play any role in the graph, but let's just state it. Frequency is b over 2 pi, which is equal to 1 over 2 pi. Okay? Alright, let's set up the window that we're going to use to generate this curve. So, window. As the center is 0, 0. So we're going to go side to side, 1 period to the left, 1 period to the right, okay? So 2 plus 2 pi to the right, and minus 2 pi to the left. So we end up with 2 pi and negative 2 pi. Up and down, 1 unit up, and then 1 unit down, -1, so go -1 down and 1 for the high point, okay? All right, let's go ahead and we're going to sketch the points. All we just need is the points for the cosine graph, and then look at the points that are at the x-axis, and that's what we use to generate our asymptotes, all right? So let's create our coordinate system like this. We're going to use, let 4 tick marks equal a period. I'm going to use 2 boxes for a tick mark, so 1, 2, 3, 4. All right, that's 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. In the other direction, 1, 2, 3, 4. This is -2 pi. This is -pi. And we can fill out the rest. All right, max and min. You go up 1, 2, 3. That's the maximum, which is 1. And then 1, 2, 3. That's the minimum. Okay, let's put that in dotted line. So this is our max right here, and our min right here. Okay. All right. Now let's go ahead and graph the points. So let's put the points in. So for the points, what does the cosine look like? Remember, the cosine is like a cup, right? Positive cosine is like a cup. So we're going to start from the maximum. Always start from your y-axis. Maximum, center, minimum, center, maximum. In the other direction, we have the maximum, center, minimum, center, maximum. Okay? The only points we care about are the points where it intersects the y-axis. So this point right here intersects the y-axis, the x-axis, here intersects the x-axis, here, and here. Okay? So anytime it hits the x-axis, that means cosine is 0. So there we are going to have a vertical asymptote. So we have a vertical asymptote here. And then we'll have another vertical asymptote here. And then we'll have another vertical asymptote here. And then we have another vertical asymptote right here. Okay? All right. So to draw the tan curve, I'm going to draw it using blue color. It goes this way. You start from the center. It starts from the center. You're going to have a snake pattern like this. Goes up like that. And then it does the opposite in the other direction. Down like that. And then here the same thing. Starts from the bottom, goes to the center like that. And then through the center, it goes up like that. All right? So now you have it going like a snake. It snakes up from the center, and it snakes down. It gets really close to the asymptote, but doesn't really touch it. Okay? So to the right from the center, it goes up like that. All right? And then this one is from the bottom. You know, if you're to the left of the center, you go down, and if you're to the right, you go up. Okay? So this is a full circle, and this is a full circle right here. So this right here is our tan function. All right. So let me take out the amplitude so you see what the tan function looks like. All right. So there goes the tan function, the function in blue. All right. So there you have it. So that is y equals tan x. Okay. Let's go ahead and take a look at how to draw the cosecant function. Okay, so for number 2, we're going to graph y equals cosecant x on -2 pi less than or equal to x, and that's less than or equal to 2 pi. Okay. All right. So first thing we need to know is when does this function have its asymptote? So what we have to do is write it as a reciprocal. So y equals cosecant x equals 1 over sine x. Okay, so anytime sine is 0, this function will have an asymptote. Okay, so let's write this function in transformational form. So cosecant in transformational form is y minus 0 equals 1 cosecant parentheses 1 times x minus 0. Okay, so this is a transformational form. So the related reciprocal function that helps me determine the asymptotes can be written in transformational form also. We're going to be looking at sine x, okay, because whenever sine x equals 0, we have an asymptote, okay? All right, so what we're going to do, we're going to write y minus 0 equals 1 sine bracket 1 times x minus 0. We're going to sketch this graph, the graph of the sine function, and use it to determine where the asymptotes are located, okay? All right, so let's do this. So first thing we're going to look at is the new origin. The new origin, notice we're graphing the sine function, okay? The new origin is 0, 0. Phase shift, there none. Vertical shift, there none. The amplitude. The amplitude is 1. That's up and down, 1 unit. The period. A period is 2 pi over b. And b in this case is 1, so it's just 2 pi. So we know that 4 ticks is going to be 2 pi. And the frequency is 1 over 2 pi. Okay, we already know how to determine that. Okay, let's set up our window so we know exactly how to fit pins in. Starting from the center, 0, 0, we're going to go left and right by the value of the period. To 2 pi to the right will take you to 2 pi. And then negative 2 pi to the left will take you to negative 2 pi. And we'll go up and down with by the value of the amplitude. So we'll go 1 up and negative 1 down. So 1, 2, 1. Okay? So there goes our window. All right, let's go ahead and sketch. We are going to sketch the dots of the sine curve. Remember, we're trying to draw the cosecant, not the sine. Okay, so be very careful what's going to happen right here. So we draw a coordinate system. 4 tick marks equals 2 pi. I'm going to use 2 boxes here. 1, 2, 3, 4. That's 2 pi. To the left, 1, 2, 3, 4. That's negative 2 pi. And that's negative pi. And that's pi. Okay? All right. Max, let's use 3 boxes for max. 1 and 1, 2, 3. Negative 1. All right? Max and min. There goes our maximum right here. And there goes our minimum. All right, now what we're going to do is we're going to graph the point that determines the sine. Remember, your sine function is like an S. So sine is like an S. Okay, so let's put the points in, okay? So we start from the center on the y-axis always. So we start from the center. Center, max, center, min, center. Okay? And then we're going to go center, min, back to the center, max, and then back to the center. Okay? All right. Now what we're going to do is we're going to draw the sine function using a dotted line. The dotted line, because this is not the graph, it's just a guide, okay? So just make your sine dotted. So dot, 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 make it dotted. This is not the graph, it's just a guide. So there goes the pattern of your sine. We can erase it later when we're done, okay? So erase, make it dotted. Dotted. Like that. Okay? Now, where are the asymptotes? Anytime this graph hits the x-axis, that's where you have your asymptotes because x is 0 at those, sine x is 0 at those points, okay? So let's go ahead and graph our asymptotes. So it's a 0 here, so there's an asymptote right here. There's a 0 here, so there's an asymptote right here. There's a 0 here, there's an asymptote there also. There's an asymptote here. And last but not the least, we have an asymptote right here. Okay. All right, let's go ahead and graph the cosecant. All you do is to graph the cosecant is you just reflect the portion of the sine graph. Okay. So you see this sine piece right here, you just reflect it upwards. Make sure you don't touch the asymptote. So you have like a U going up this direction, and then a U going up the other direction, like that. Let me draw that again. That doesn't look good. So you go like this, just like the sine in that direction. And then here you have the U going the opposite direction, like this. Try your best not to let your line touch the asymptote. Remember, we have an asymptote right here, okay? And then here you reflect the U upwards, goes like this. And then this one goes up like that. And then this one goes down like this. And this other one goes down like that. Okay? Let me curve that a little bit more. So you just curve it in this orientation. Okay? So that goes, the black one is your tan curve, okay? And now let's erase our sine so people don't get confused. So just take out that blue thing that you drew on the inside. You can take that out. Alright, take that out, take that out, take that out. And what you have left, this is your cosecant function. Okay, from 2 pi, from negative 2 pi to 2 pi, so this is y equals cosecant x. Alright, so there you have it. Alright, so next we're going to take a look at a secant example. So in this case, let's try this one, something that's slightly more complicated. How about number 3? We want to graph y equals negative 3 secant x on the interval negative 2 pi all the way to 2 pi. Okay? All right, let's do this. So first of all, we have to express this as a reciprocal function. So y equals negative 3 secant x. All right, so we need to determine where the asymptotes are at. So what is secant x in reciprocal form? Secant x is equal to 1 over cosine x. Okay, so whenever cosine x is 0, we have an asymptote. Okay, all right, so let's take a look at this particular case that we have right here. I'm going to write this in transformational form. Y minus 0 equals negative 3 secant bracket 1 parenthesis x minus 0. Okay. Now, what is the related reciprocal function that's going to guide my construction of the secant? It's going to be the cosine, right? So what I'm going to graph is this function, y minus 0 equals negative 3 cosine bracket 1 x minus 0. After graphing this, I'll use the asymptotes and the reflections to figure out what the secant function looks like, okay? So this is what we're graphing right here. Now, let's find the relevant components, the new origin. The new origin is 0, 0. The phase shift, they're none, because you have 0 on the x. The vertical shift is none also. The amplitude is absolute value of negative 3, which is just 3. That's up and down. The period is 2 pi over b. So in this case, it's going to be 2 pi over 1, which is just 2 pi. And our frequency is the reciprocal of the period, which is 1 over 2 pi. Okay? All right, let's go side to side. Okay, let's set up our window so that we can draw this graph correctly. So the window, the new origin is 0, 0. So side to side, we're going to go 1 period to the left, 1 period to the right. The period is 2 pi in this case. So positive 2 pi to the right, negative 2 pi to the left. That means I'm going to go 2 pi all the way to the left, to the right, and negative 2 pi all the way to the left. Up and down, I'm going to go 3 units. Okay, so 3 units up, 3 units down, -3. So this is a window that defines my graph. All right, let's go ahead and sketch the curve. We draw our y-axis first, and then our x-axis. My x and my y, sorry. And then calibration, 4 ticks, gives me a period. So let's use 2 boxes for a tick right here. So 1, 2, 3, 4. So that's 2 pi. Okay, and then that's pi. And then the other direction, 1, 2, 3, 4. And that's -2 pi. And then that's -pi. Okay. All right. Now, we need our max and min. Let's use 3 boxes for our max. And then 3 boxes down for our min. Alright, so there you have it. Now let's connect the dots for our cosine function. Remember, cosine x is like a cup, right? Like a cup. But we have a negative cosine here, so what is that going to look like? It's like the cup is flipped upside down, so it's going to be like this. Okay? So the orientation of our points is going to be in this pattern, to the right and to the left. Okay, so starting from the y-axis, that's where we always start, sine or cosine. Starting from the y, we start from the low, the minimum. So we have min, center, max, center, min. Okay? And then the other direction, min, center, max, center, min. Okay? Alright, let's draw the dotted line for our cosine. Remember, we are drawing the question asks for secant, not cosine. Okay, so every other graph has to be dotted. So let's make a dotted graph. Curve out the center, straight. So the center, curve at the max. Curve out the max, straight through the center, straight out the center. Curve at the min, curve out the min, straight to the center. Straight out the center, curve at the max, curve out the max, straight to the center, straight through the center, and then curve at the min. Okay? Alright, so this is your cosine curve, okay? So now that's going to help us draw the asymptotes. Anywhere the graph hits the x-axis, cosine is negative at that value. So there goes our asymptote, the first one. There goes our second asymptote. There goes the third one. Anywhere the graph hits the x-axis, okay? And asymptote. And then there goes the last asymptote from -2 pi to 2 pi. Okay? Alright, so to draw our secant curve, all we just do is we're just going to flip these pieces. Okay? So let me show you how that works. You see this? We have this piece right here. We're going to reflect it downwards. It's going to go this way. That's one piece. And then this piece gets reflected upwards. So it looks something like this. Let me try that again. So it looks something like this. Curve towards the asymptote. And then this goes like that, curves towards the asymptote. This one reflects downwards, like that, curves towards the asymptote. Try your best not to let it touch the asymptote. Curves towards it. And then this one curves towards the asymptote. And then this one also curves towards the asymptote. And this last piece right here, you just reflect this piece downwards, curves towards the asymptote like that. Okay? Alright, now let's eliminate the cosine graph so we can see our answer. So this cosine is not actually what we're looking for, so let's take that out. It was just to guide that reflection, okay, and also the construction of our asymptote. So let's take that out, take that out, take that out, take that out, and take that out. Okay? So what we have just generated is a graph of, this is a graph of y equals -3 secant x. Okay, that's what the original question asked for, -3 secant x. So this piece right here is your graph. Okay, so there you have it. But thanks so much for taking the time to watch this video. Feel free to subscribe to my channel just by clicking up here. More videos can be found on myprchef.com. Thanks again and have a wonderful day.